We will solve this today's LeetCode problem. This is a LeetCode medium, sum of square numbers. So basically, it's uh, very common questions nowadays, right? But in this, you can solve it very in very different approaches. So let's see what how we can solve this. So we have given a non-negative integer c, and we need to decide whether there are two integers a and b such that a square plus b squared is equals to c, right? So basically, we need to find two. We need to tell it that whether we can find two integers whose squares and whose sum of squares is equals to c or not, right? Basically, that's the question. So it's basically a square plus b squared is equals to c, right? So uh, how we can do this, right? So basically, it's if you take an log of this question as sum of two numbers is equals to c, right? As sum of two numbers to some problem and solve this, it would be easy for you to take, right? So what we do in two some problems, we definitely uh, iterate in whole array, and basically see that which two numbers can form the specific target, which is here is c, right? That's the we do into some problems. Here in this we can do the similar things, because here we need to take a square plus b square. So here we have given c is equals to 5, and for the first example c is equals to 5. So what we can do, we can simply check from 1 to from 1 to root c value. Root c, why root c? Because square root c, right? Why root c? Because this is an square, right? This is an square. If I take a is equals to 0, anyhow the smallest number I can take, a is equals to 0, then how much time this b becomes? B will become, if I take a 0, then at most b can go to root c, right? At most b can go to root c. So this is the maximum possible values of any number which is possible. So I have taken square root c, right? Basically, right? So what can I do? I will go to from 1 to square root c till square root c, and definitely I can store, I can uh, or I don't store, right? I definitely not store. What I will do, I will simply move to every number 1, 4. It's a square value, right? 1, 4, 9, 16, then 25, 36, right? This is the square root of 1, 2, 3, 4, 5, 6, 7, right? Right? This is a square root. So what we can do, this we will use just as to some problems, that instead of taking 1, 2, 3, 4, I can take a square. So this is something like a b c d, right? And now in this I need to find, I just need to, sorry, I just need to find two numbers which summation equals to c, right? That's the thing. Now this a square becomes a, b square becomes b, and now we need to find a plus b is equals to c in this, right? So what we can do, we can just simply move in this array, move in this uh, not this array, because I don't need to store this. Why? Because I will tell you this. If you want to store, you can store till where? Till root c value, which is equals to 5, root c is 2, which is, and you can store to 3 also, right? Or you can take root c plus 1, right? So for safety purpose, so what we can do is we will move to 1 from 1, right? We will start from 1. So this one and 5 minus 1 is 4, right? 5 minus 1 is 4. So we will check, we will have one, and we will check that whether we have 5 minus 1 is equals to 4 or not. No, I don't have anything, right? I don't have anything. So I will simply, what I can do is I can simply store this one as that I have achieved this, and I have not got 5 minus 4, right? I will go to 4. Now we'll check that 5 minus 4 is 1. Is 1 is with B? Yes, I have 1. I have 1, right? It means what does it mean? It means I got 1. I got 1. I got 1, right? I got 1 is, it means this 5 is This means this 5 will definitely can form by any two numbers which are present here. If I got 1, it means the number is present, so it means I will can simply return true, right? So this is the, just as a two sum problem, right? This is just as a two sum problem. Because I have just used a hash map here. I will just use a hash map to move iterate in this, and if I'm getting a c minus the current number, then I'm checking that whether it is present in my hash map previous or not. If it is not present, then I have uh, I'm uh, I'm assigning this the current number to my map. Suppose this c becomes suppose this C is now 17. Suppose this c is now 17, or let's just let it be 20, right? Let it be 20. So how do we know that whether it is cuneiform? So suppose we come at 20 minus 1, which is 19. It is not present here, right? It is not present here. When we go to 4, 20 minus 4 is 16, which is already not present here. So I will store this, right? I will store this to check further. 9, 20 minus 9 is 11, which is not present, so I will store 9 also. Now 16, 20 minus 16 is equals to 4. See, 4 is already present here, right? 4 is already present here, and we will move till root c only. Root c only. And what is root c? What is root c? Till 25, till of 16 only. Only 16, right? These numbers are neglected. I have just shows you to. So 16 minus 20 minus 16 is 4. 4 is already available. It means I got some numbers. But what if it is 21? If it is 21, if it's 21, then we don't get any numbers which can be summation to 21, right? So it means we return false in that case. So it's a simple case of hash map. It's a simple case of hash map that just take analog with to some problem. It's a very basic problem. I have already made video on this. If you want, I can give an I button. I can give you link the link. It's a very simple problem. So it's basically what will the time complexity for this, right? What will the time complexity for this? So basically I have started from 1, iterating from 1 to till square root c, till square root c, right? So from 1 to square root c, so that will be definitely o of root c, o of square root of c, right? Definitely o of square root c. And for I'm taking unordered map, I'm taking a hash map for that, for checking each and every number that will give me o of 1. But in other languages it can go to uh, o of log of o of log of n, right? So in c++, it will be checking for every number that is really o of n. So basically it will be o of square root of c, right? O of square root of c, right? So if you don't use a hash map also, it is already solvable. It will be also solvable by how? See, the thing is, when you iterate from 1 to, when you iterate from 0 to root c, which is equals to like this is also root c, right? I into I less than equals to c, and I plus plus, this is just as root c. But when you write like this, when you write like this, sometimes it gives, sometimes it gives, it can give what? TLE. Why? Because whenever this loop runs, this square root will function, and this uh, square root c has time complexity, will be worst time complexity is log of n, log of c. The worst type of concept is log of c. So basically whenever you whenever this for loop run, whenever this I incremented, whenever this I have started, this square root will again compute every time, each and every time it will compute. So sometimes it can give you TLE, sometimes it can give you TLE, sometimes it can give you TLE. So always remember that, don't write like this, don't write like this is wrong. This is not wrong, of course, this is, but this can give you sometimes TLE. Always try to write like this, always try to write like this, write like this, right? This is the same as written as this, but when you write like this will give, this will compute each and every time when you, when this index is incremented, right? So it can go sometimes, sometimes it can give you TLE, right? So basically try to write like this always: I into I less than equals to 6. So how this will be benefited? So the same thing, right? When we started from I will check C minus. I will check that C minus this I into I existed or it existed in my map or not, existed in my map or not. And if it existed, I will just return true, and otherwise I will just store in my map, right? But the problem is the time complexity is square root of C, but we the space complexity is something which is O of square root of not a square root of C, of course. It will be from 0 to root C, right? So that would be root C. mm, Art chart 860, yeah, that would be root C. That would be root C, right? So that would be root C, right? But this is this is square root of C is achievable. But how, why this square root of C? Can we do this in O of 1? Can we do this in O of 1? Let's see on that also, right? So one thing, you see that what I'm doing, I am stating from 0 to root C and checking for each and every value from C minus I square. And if you have so, and I'm starting at starting, I told you to take analog, told you to take analog this question with this question with to some problem, right? To some problem. And if you see here in this case, in this case if from 0 to root C, from 0 to root C, it is sorted, it is in sorted order, it is in increasing order from 0, then 1, then 2, then 3, then 4, then 5, then 6, right? This is in sorted order, right? And if it is in sorted order, can we apply one thing? Can we apply two pointer approach? Can we apply? Let's see. Can we apply two pointer? So basically, if suppose you have given in increasing order the number, and you need to apply to some problem, what you do? You just move from start and end point and take the summation and check whether the summation value is greater than the target value or less than the target value, and increment and decrement the lower pointer and the high pointer, end pointer, right? Start pointer, end pointer. That's you do, right? We will do the same thing, we will do the same thing in this. So what we do we will take two pointers, which will be low pointer, which is will be start at 0, and the end pointer, which is at root C, which will be at root C, which will at root C, right? So this square root C is gives us double, right? But this end will give us integer value. It is an integer value, so that would be an integer value. So what we will do, we will start from, suppose this is square root C, C is 20, is 25. Let's take a small number, that is 25, right? So when we move from, let's suppose it is 26, right? So square root of C is low is 0, and square root of C is 5, right? 5 point something, but it is an integer value, so it will round up to 5. So from starting from 0 to 1, 2, 3, 4, 5, so we will have this 5. Now I am telling that I am at this position, I am at this position. So the naming convention should be changed, low and high, right? So and I am at this position, high, right? So when I take the summation of this low and high, so this will become 0 plus 5. So it is get so this becomes 0. So I need to take not summation, I need to take a square now. I need to take, see, a square plus b square, so I need to take low square plus high square. So 0 into 0, 0 into 0, and 5 into 5, which is equals to 25. This 25 is less than this 26. This 25 is less than 26. It means I need to definitely increase my value. So for increasing my value, which pointer should be increase or decrease? You told me that you think. Of course I need to increase this low value. I cannot increase this high value because it is already at end point. So I need to increase this low value, so I will increment my lower pointer. So when I increment my lower pointer, it becomes at this 1 point, right? And this high is at still at 5. So when I again take the low plus high, this is not low plus high, this is low into low plus high, right? This is low into low plus high, right? So when I again do this, this will be 1 into 1 plus 5 into 5, which is equals to 26. So which is equals to 26, it means I have achieved my target. It means I will definitely got a summation value, two numbers, right? So that will return true, right? That will return true. But if you suppose it was 16, it was instead of this 26, uh, it was 17, right? It was 17, suppose. So for 17, in first case it was becoming 25. Now 25 is greater than 17. 25 is greater than 17. So 25 is greater than 17, it means I need to decrease any number which so that I can go decrease this 25 to 17. So for decreasing, which pointer should need to decrease or increment? Of course high numbers. So high should be reduced to minus minus, right? Now high should be reduced to minus minus, it means this high will now move to this 4 value, right? Now this 4 value should be 4 into 4. Now it becomes 16, right? And 16 is less than 17. 16 is less than 17, right? 16 is less than 17. Now 17 is greater than 16, it means I need to increment the number to increase this 16 to 17. So what I will do, I will increase the lower pointer. So low becomes at 1 and high is at still 4, right? So when I do this, this 0 will becomes at 1 and 4 is still at here. So it will become 17, which is equals to this 17, the our target value. So it means I definitely got a 1 and it will be returned true, right? So this is how we will solve this question. So basically what I'm doing, I'm iterating low plus plus or high minus minus. So basically the constraints will be this one only, right? Low should be always less than high, because low is moving forward and high is less than. So if high is greater than if high is value is less than low, it will be eliminated, right? And this is how, this is a simple two pointer approach. This is simple two pointer approach, right? This is simple pointer approach. So what we are doing, we will we are just taking low into low plus high into high, or instead of this I will just take a as low into low, b should be high into high, and if a plus b is greater than c, what I will do, I will decrement my high minus minus. And if a plus b, or if a plus b is equals to c, if a plus b is equals to c, I will just return true from here, because I got definitely got two numbers, right? I will just return true. And if it is not, then I will check a plus b greater than c, high minus minus. If a plus b is less than c, I will increment that. And this is how we will solve this problem. And if we don't get return true for any here, it means it will be zero simply, or false, right? So this is the approach. Basically it's simply two pointer approach. So what will the time complexity for this? Time complexity would be O of root c, square root c, because we have started this low. If you see, we have started this low from 0 to high square root c, right? So this will be the range from 0 to high is square root of c. So this will be the approach, right? So basically square root of c. And space complexity, the main thing is here that we have reduced space complexity from O of square root of c to O of 1 here, because we are using only variables, right? Now this would be the simple approach. There are other methods also. There are other methods to solve this also, right? But they have the higher complexity, right? Either you can use binary search and all, but that will take over fruit c log c some type something, right? Because you need to check each and every number by binary searching. But this is an optimal solution for that. Let's try to just implement this, and I will just use this pseudocode for me, and let's just comment this. Right. Let's just paste this, and yeah, I think we need to make some changes here. Okay, let's just analyze that whether we need to write int or long. This is to the power 31 minus 1, right? So 10 to the power 5 is can be the simply go, and here high is at root seed, because so that would be can go to 10, greater than 10 to the power 9, right? So that can give you at the edge case 2 to the power 31 minus 1 TLE when you do high into high, right? So basically, just for going to safe side, I am taking long, or just type there long. This is a macro. You should use this for saving your time, right? This is just an implementation purpose how you implement, and basically, yeah, this is how we can solve this, right? So just return false or true. Let's try to run this. Let's see, is there any compilation error or not? There is compilation error. What's the error? A type specifier is required for all declaration already declared, yeah. What's wrong? mm, I think I have done this correctly. Something is missing, I think. Let's leave this and let's write long. It is something else. A type specifier is required for all declaration. Oh, okay, sorry. This is the error. This was the error. Right. Okay, this is good. We are good here. This was on line 77. I was not focusing on that. Let's run this. Yeah, let's submit it. Yeah, we have done. Uh, so this is new feature by LeetCode. This is square root c. You can see that also, right? So yeah, this is how we can solve this problem. So I've already told you time and the space complexity. So thank you so much. Bye bye.